Here is question number 41, everyone. Hydrogen atom in ground state is excited by a monochromatic radiation of wavelength lambda equals 1025 angstrom. The possible number of emission spectral lines in spectrum will be what? HC we have to take 12400 electron volt angstrom. Now the number of spectral lines is given by n into n minus 1 divided by 2, where small n is the state, nth state, first, second, third, fourth, whatever it is. Now first of all we have to decide whether or where electron is going after absorbing this much amount of energy. So E will be what? Minus E1 plus Hc by lambda. Minus E1 is 13.6 plus Hc, that is 12400, divided by lambda, that is 1025. Now solving it gets you minus of 13.6 plus of 12.09, and finally the energy we will get minus of 1.502 electron volt. Now for hydrogen, minus 1.502 electron volt energy is associated with third state. So therefore n equals to 3, as this E is equivalent to energy in third state. So finally we can calculate capital N, that is 3 into 3 minus 1 divided by 2. So total number of spectral lines is 3. So we'll go with option number 4, which is absolutely correct. Now move on to the next, that is 42 number. So here is question number 42, everyone. A radioactive element uranium 92-38 undergoes successive radioactive decay and decays into lead 82-206. The number of alpha and beta minus particle emitted respectively will be what? Okay, so here is uranium nucleus 92-238, and after successive decay, Pb left and alpha and beta particles are emitted. Suppose m alpha particles are emitted and n beta particles are emitted. Alpha 24, beta minus 1, 0. Now mass number must be conserved. So therefore we can write 238 equals 206 plus 4 times m. And after solving for m, we will get the value of m as 8. So finally we got number of alpha particle. Now let's solve for beta as well. We are knowing very well that number of proton must also be conserved. This atomic number must be conserved. So 92 equals 82 plus 2m minus n. 92 minus 82 minus 2m equals minus n. Putting the value of m here, we already have calculated it. We get 92 minus 82, that is 10 minus 2 into 8 equals minus n. 16, 10 minus 16, that is minus 6 equals minus n. So finally n is 6, that is beta minus particle. M is 8, that is number of alpha particle. So 8 alpha, 6 beta, alpha and beta. Finally we will go with option number 3, which is absolutely correct. Now move on to the next, that is 43 number. So here is question number 43, everyone. A radioactive sample is decayed by 20% in one day. After next 2 days, the undecayed percentage of nuclei will be what? So for example, suppose n number of nuclei will remain. So we have to calculate n upon n naught multiplied by 100. This is what we have to calculate first of all. Now we are knowing that number of nuclei left, active nuclei left, is n naught e to the power minus lambda t. T 1 day and n is decayed by 20%. So the left amount is what? 80%. So 80 by 100 N naught equals N naught e to the power minus lambda t. 4 by 5 equals e to the power minus lambda t equals 1 day. So 1 only we have to put here. So we have got the value of e to the power lambda minus, that is 4 by 5, equation number 1. Now we have to talk about next 2 days, means after 3 days from the beginning. So number of active nuclei left equals n naught e to the power minus 3 lambda, or we can write n naught e to the power minus lambda cube. Minus lambda we have calculated 4 by 5, so n by n naught equals 4 by 5 cube, or n by n naught equals 64 divided by 125. What we have to calculate? N upon n naught into 100. So let's multiply both sides. We will get n by n naught into 100 equals 64 upon 125 into 100. 25 4 ja, 25 5 ja, and after solving we will get in percentage 51.2% of n naught. So we can say that option number 1 is absolutely correct. We can go with this first option. Now move on to the next, that is 44 number. So this is 44th question, everyone. A voltage between terminal A and B is 20 volt given, and Zener breakdown is 7 volt. Then the potential difference across 6 ohm resistance will be what? The Zener voltage is given, that is 7 voltage. It means 7 voltage will be fixed here and it is not changing across this Zener diode. Suppose I current is flowing. Now we can apply the KVL starting from B to A. 20 minus 6I minus 4I minus 7. We finally reached at B again, so 0. From here we have got the value of current I, that is 1.3 ampere. Now the potential difference across this 6 ohm, that is V, will be what? I into R, that is 1.3 into 6 volt, and after solving we'll get the value 7.8 volt. So we can say that option number 2 is absolutely correct. We'll go with this option. Now move on to the next, that is 45 number. So here is question number 45, everyone. The logic gate realized from the circuit as shown in figure is where A and B are input and Y is output. So this is the type of circuit given. Now what kind of gate this circuit is acting, we can get it from the truth table. So this is A, this is B, and this is output Y. Suppose initially both switches are off, so A0, B0. Now all the current is finally reaching at RL, so we will get output high at Y, so it is 1. Now if switch A is closed but B is on, still current will not go through AB and all the current will move through RL, so we will get output high at Y. B is high, A is low. Again all current will move to RL and will get output high again if both switches are closed. So 1 1. If both switches will be closed, then here there is no potential difference or zero potential difference. So therefore we will get low as output. So looking at the truth table, it is clear that this output has the right combination like NAND gate. So the circuit is acting as NAND gate operation. So that's why we will go with option number 4, which is absolutely correct. So physics portion has been done. Bye bye everyone. God bless you all. Thank you. All the very best.